Good afternoon guys, I'm Chris and welcome back to this Wednesday's episode of Rift Amps. I just wanted to say a quick thank you to everyone who's ordered a JM1 watt head from me over the past couple of weeks. You remember I did kind of a soft launch on this. It was a custom build for Jerome, and it turned out so well that I decided to offer it as a full-time model in my lineup. The response has been great. I've taken quite a few orders for them, so thank you to everyone who actually ordered one. Quite a lot of inquiries from people who are asking if I could do it as a combo. As I said from the beginning, it's not going to be available as a combo. It is a small portable head only. So sorry about it. The idea is that you can just take it and plug it into whatever speaker cab is in your rehearsal room, your studio, your bedroom, whatever. And the idea is that you can just dial it in and use that whatever cab it's plugged into. I don't want to be going down the whole route of designing and tuning a small combo cab, because it just adds expense that we don't want to be doing, especially when I've managed to get an amp below £1,000 UK price, right? So no combos, I'm afraid. I'm really, really sorry about that. Perhaps in the future we might revisit it, but I wanted just to have a 1 watt head in the lineup, and I've got one and it's great. It's really, really cool. So there is that. For those that have ordered it, I have decided to make a tiny change to the cabinet size. The one that you'll see on the website, the one that we built for Jerome, is quite tall and quite narrow, so it's a bit of a boxy size head. For the ones I'm going to be doing moving forward, we are going to squash it a tiny bit. We had a bit more height headroom than we actually needed, but also I'd like to bring it out slightly just so we get the height to width ratio more familiar to the classic amps that are out there. So we're going to try and do that, get that perspective, that ratio right. Or more familiar to you guys. But if you want the original cabinet design, you've already ordered one, we can do that for you, no problem. But unless I hear otherwise, I will be doing them in the slightly revised head shell design. Right, Q&A time then. Did quite a few videos last week, didn't we? I think we've got 4 videos out. So I've had lots of comments, a lot of similar comments. So as usual, standard rules apply. If I don't get to your comment, it's because it's probably very similar to one I've already answered. I need my black wire for this. So we'll start with RFO, who says, genuine question re safe design, which you are clearly and rightly passionate about. Really surprised that 2-Rock had the fuse after the switch. Yeah, me too, actually. Anyway, his question, the 2024 British Standard EN 62368-1, which is a copy of the EN and IEC 62368-1, by the way, promotes a hazard-based approach to amplifier design, etc. How do you think that will impact the DC side of things? Screening the AC inputs is good, or sleeving them and isolating them, but they're not the most dangerous voltages in an amp. If you start to follow the logic through, will that drive screening of all the points where hazardous voltages exist? No, it won't. And it comes down to, I'm just going to bring this up because I want to get this right, who it is you're trying to protect and the dangers that you are exposing them to. And the standard lists 3 different types of persons. The first one is the ordinary person. I'm going to read this out word for word. So an ordinary person is the term applied to all persons other than instructed and skilled persons, okay, which are the other 2 types. Ordinary persons include not only users of that equipment, but also all persons who may have access to the equipment or who may be in the vicinity of the equipment. So let's take, for example, your washing machine at home. You, as the user, you're the ordinary person in that example. You're using that device for its intended purpose, right? And so all of the applied safety measures and processes involved are to protect you, okay? And also anyone around it. Now, we always use the 3 Ps and the 3 Ps are the things that you as a manufacturer are trying to protect, or you must protect. That's persons, property, and pets. So you mustn't expose any of those 3 to damage, injury, fire, or anything like that. So you've got to protect those 3 groups: people, property, and pets. Okay. In the example of our dishwasher or washing machine, can't remember what I said. You as the home user are the ordinary person. The instructed person or the skilled person would be the service and repair techs or the designers. Okay. Now, in your question, you said the DC voltages inside the amp are far more dangerous than the AC. That may not necessarily be true, but as the designer or manufacturer of an amplifier, the ordinary person, i.e. the user or somebody who's in the vicinity of that device being used, should not be exposed to any DC at all in its standard normal operation. Unless they deliberately take the item apart, they should not be exposed to any DC. For example, with a guitar amplifier, and you're going to have to remove the chassis to get to any DC. Now, you could get to a high voltage DC point, one of the valve pin sockets, right? But to get to that, 1, you're going to have to remove the back panel. 2, you're going to have to remove the valves. 3, you're going to have to plug the amplifier in, turn it on, then stick something up into a valve socket to actually get to any DC. Now, you can't fix idiot, right? But you can provide instructions. Now, why do we sleeve the AC? Well, there's many reasons because of that. But one of the reasons is that it is entirely expected and reasonable that the user of the amplifier might want to change the mains cable if it's a detachable mains cable, or that they might want to change the mains fuse for whatever reason that may be. And providing you provide safe instruction on how that is done, that's okay. But what they mustn't be able to do is expose themselves to risk of electric shock whilst doing so. So that's one of the reasons those terminals must be done in a certain way, in terms of the configuration of them, the attachment of them, the strain relieving of them, etc., the shielding, etc., etc., all that kind of stuff, right? So when it comes to your question, which saying, do you then go to the point where, or even your DC things are screened, then no, because the only way to access those properly will be in the service and maintenance of the amplifier, which will be done by an instructed or skilled person. So which is why you'll always see on the back of an amplifier or in the instruction manual, no user serviceable parts inside is the usual text that's used, refer all servicing to qualified personnel, etc., etc. So the end user isn't exposed to those, cannot be exposed to those unless they deliberately dismantle the amplifier. Hopefully I've explained that properly. If you read through the standards, you'll understand, and it even includes workflows and flow diagrams, and all that kind of stuff to help you understand what goes on. What was interesting though, is as I was looking through it, it does say that in order to be classed as either an instructed or skilled person, both Australia and Germany have certain requirements for that. So you may need to carry an official qualification to work on those amplifiers in those countries. So very, very interesting. But what a great question. Really, really interesting. But if you zoom out and say, right, well, who am I trying to protect with this? Well, the end user is the main person. Is there any way that those people can be exposed to DC? No, that shouldn't be a case. And if they get to a scenario where they could be, you've provided reasonable and detailed instructions as to how to avoid that. Chris Phillips says, love watching you prototype, talking about the basement and figuring it all out. Thank you for your question and comment, Chris. Have you thought about flipping the phase inverter plates, coupling caps, and the 220k circuit around so you invert them? I do this as best practice to keep my grid wires as short as possible. Learned this from Gerald Webber before he passed. Yes, I had considered it, and it is, for me at least, circuit dependent. There are some of my designs where I do that. The problem is in the way that if you use a standard centralized board, as I do, by inverting it, you are then lengthening the input leads from the phase inverter to those coupling caps. So sometimes it's beneficial, sometimes it's not. I do it on my Plexi 18 model. I do it on my Brown Deluxe builds, but quite often on black panel style builds like that, there's often very little need unless you're running into something of a very particular issue. When that can become beneficial. So it's a case-by-case basis. That's what I'm trying to say. So, but yeah, great tip, great point. I didn't realise it was one of Gerald Webber's things. I just thought it was kind of common knowledge, but there you go. Right then, the twin, which is, I'll put some light on it for you, one of the heaviest beasts I've ever come across. This thing is ridiculous, and it's come in for no output, will not power on. And I explained this in last week's video. When the customer dropped it off, the mains fuse had popped, and I don't know what I've done with it. There it is. I'll come and show you. So there it is, there's the mains fuse, and it has popped. Now we popped another fuse in, and the thing fired up, but there was no sound, and there's no dual light either. I shall show you. So that's on. If I turn the amp on, I can hear the transformer hum and buzz. Dual light doesn't work, but that is loose as well. That might be a clue. But if I rotate you around, you can see that the two green LEDs on the rear, these turn red when one of the screen grids, when the screen fuse blows. So I wonder what's behind here. Can't say I've worked on one of these before. Ah, look, there's fuses behind here as well. So amp off. We need to have a look inside. We need to work out what's going on. But let's just, for the sake of things that are interesting, let's pop this fuse out. That one's okay. And let's try this one. My assumption is that this LED is linked to this fuse here, which is why they're both good. Do you know what we could do? We could test that theory. Amplifier back on. If I pull this fuse, it turns red. There you go. Right. That does make sense then. Right, let's get this thing apart so we can have a look inside, because I don't know what these are like inside. I don't know how tricky they are to work on. I don't know how complex they are. I don't know what we're opening ourselves up for. But we need to work out why this thing lost output and then popped the fuse. Right. Out we come. Right. Speaking about the 2-rock, Bazza the Great says, the thing I like the most about the built-in Faraday cage cover for the amp chassis is it is an extra layer if you're not supposed to be in there. Yes, it's an extra protective layer. You're right. It gives an extra deterrent to keep hands out that shouldn't be in there. Yes, yeah, I think that's a very good point, actually. In that it makes the internals of the amplifier more difficult to get into, and then hopefully someone would question that and say, should I be in here? Should I be poking around? Should I be referring this to qualified personnel? I think that's a very good point, Baz. Great question, great comment. Look forward to more of them. ATEC9020 says that is hideous in regards to the basic failure on compliance back on the 2-rock here. Beyond that, my understanding is that the terminals at the mains input receptacle and power switch are supposed to be a mechanical connection as well, not soldered directly to the components. Now, you're ever so slightly wrong there, in that, yes, it must be a mechanical connection, but that can be simply with a J hook on your wire through the terminal and then soldered into place. What you can't do is what we refer to as soft soldering, which is simply just tack soldering it onto the terminal and sleeving it. There's no mechanical thing there, but you can do it with a J hook. You don't have to use push-on connectors. But yeah, it's, again, you have to read the regulations to understand. I mean, it actually says here, the end of a stranded conductor must not be consolidated by soft soldering at places where the conductor is subject to contact pressure unless the method of clamping is designed so as to reduce the likelihood of a bad contact due to cold flow of the solder. So all of that stuff is covered, but you do have to go into the detail and read it to understand. So you can do... so I haven't got one here, but on those AC mains things, if you will have a little solder hole. I mean, they're actually called solder tabs anyway, that you go through the wire, J-hook it round, then solder into place. That's fine. What you mustn't do is just tack solder it and call that good. So yeah, but oh, you had something else to say actually. It is also hideous that a top shelf company such as 2-rock are selling amps with IC, Illinois capacitor components. IC is not top grade. I also just can't wrap my head around using at least 3 different brands of caps for the power supply. Just pick one, then at least you can have some level of quality control over time. That is a lot of money to spend on not top shelf parts. Well, devil's advocate here. We don't know whether the caps in that amp are all original. Maybe someone else has been in them in the past and replaced them. We don't know that. We're assuming that is the case. But, you know, I wasn't there. I haven't got a crystal ball, so I don't know. And then you said that's a lot of money to spend on not top shelf parts. I mean, I kind of agree with you. I mean, not all of the components I use in my amplifiers are the most expensive, which I guess is what you mean by top shelf. But I use them because they sound the best and I get good reliability out of them. All right. The bonus is that, you know, they're not too expensive. The Panasonic coupling caps that I use, they're not the most expensive caps in the world, but they sound great and I have a very, very small failure rate on them. So yes, they, you know, I could use expensive bits, but do I get the same audio quality and performance out of them? No, I don't. So that's why So I don't think that as a blanket statement that's entirely fair, but I do take your point. I do understand it. And yes, you know, at least if you open up an amp that's cost many thousands of dollars or pounds, you would want to see a reasonable quality item used. Okay. 1, 2, 3, 4, 5, 6, 7 ICs. None of them look as though they're leaky. I'm just having a look. I do not see any sign of spillage, burning, fire damage, anything like that. It's looking pretty clean. Let's tighten up that dual light housing. That's exactly what these spanners are for. That's better. Right, sorry about that. Right, I'm looking for some other internal fuses then, because why aren't our heaters working? You a fuse? You are a fuse. And that looks like it's popped. That's a 10 amp, 250 volt fuse. Is that the heater fuse? $10 amp, 250 volt. 6.3 amps is the highest I've got there. What do we have in here? 50 milliamp. God, that's small. 6.3 amps slow blow. 250 milliamp slow blow. 100 milliamp slow blow. I don't think I want any 10 amp slow blows. We may have fallen at the first hurdle. So, I suspect what we've got is a valve failure. I suspect what we have is a valve failure that's taken out some fuses. So I'm going to go ahead and order some 10 amp fuses. I need to check that's actually the correct value that should be in here because it's not labelled. Although, is that what it should be? Should it be a 5 amp fuse and someone's fitted a 10 amp? We need to look this up, don't we? Let's spin this thing over. Oh, I wonder which one was getting hot. Would you like to have a guess? Do we think it was this one? What do you think? Right. I'm going to look up the correct fuse value for that internal fuse. And we'll go from there. Ian Thacker, a regular commenter. Welcome back, Ian. He says, it's all in the planning, Chris. Loving the work on your custom build. You're welcome, mate. Thanks for watching. I'd considered moving the preamp filter node on my Princeton build to the right of the phase inverter, but also wanted to have the option of a switchable B+ for the phase inverter between the C and D nodes, i.e. the Stokes mod, if I felt I needed more headroom on the phase inverter. I think I'm on revision 5 of the layout now. I haven't even switched the soldering on yet for the build. You could spend hours, mate, going back and forth, to be honest. He says, question about the first filter caps, or the reservoir caps in the filter section of the 100 watt Bassman. I can see you've got one reversed with a connection between the positive and terminals and resistors between the positive and negative on each. What does that do? Are they discharge resistors and those first two caps end up effectively in parallel to create a larger capacitance value? No, it's your standard totem pole, mate. Two caps in series, bypassed or split with two 220k balancing resistors to equally split the load between them. Couple of videos back, quite a few videos back now, I explained rather the way I've drawn it there with one flipped, a connection between two positive and then the two 220k's like that. is simply a space saving thing. It's just another way to draw out a totem pole reservoir cap, saving space. So essentially we've taken the two caps like that, I've split one like that, and then made the connections that way. That's all it is. So two caps in series, if it's just two caps, you get double the voltage rating, but you get half the capacitance. So they're 100 microfarads, so you're going to be dropping down to... Are they 100 microfarad? Or are they 220s? Yeah, they're 100 microfarads at 350 volts. So that's going to end up me with a 50 microfarad, 700 volt capacitor. All right, that's all that is. It's just a space-saving technique. It's Red-Jeweled or it's Regal DF. I'm never sure, and I do apologise. He said, just a general thought on running a US amp via step-down transformer on UK mains. As US mains are 60 Hz rather than our 50 Hz that we have, the US main transformer would have to be fed with about 80% of their rated primary voltage for not baking the iron by over-magnetising it. But then all the output voltages would also be lower. Are those US main transformers accordingly overrated to digest 50 Hz mains frequency? Yes, they are, quite simply. They've always been built, at least my understanding of it, with all the transformer nerds I've spoken to. Those old Schumachers and those old triads, they've always been capable of running at both 50 and 60 Hz. So it's really not the issue that people think it might be. But what I often say to people is those our step-down transformers don't always put out the correct US voltage. Some of them are 115 volts, some of them 117, some of them are 120, some are even 125, but that all fluctuates with our mains voltage anyway. So what my preference to do is, with any amp that gets imported into the UK, is pull the old transformer out, keep it safe, because it can always be installed back in, put a nice modern quality unit from a reputable supplier that's rated for UK voltage, proper UK voltage, not the harmonised bullshit. Then the amp's always going to run great. You're going to get your correct secondary voltages where you want them to be. And if you ever do come to sell the amp, we can just stick the old one back in, and it's back to normal. And if you're worried about virgin solder joints, well, it doesn't matter because the amp's getting a recap anyway. But yeah, you said the thought is that cold burny spell that Ollie experienced after some running time of that amp maybe have come from the main transformer. No, it's as I think I demonstrated on a video, one of the videos. It was a valve running away, getting red hot. I've done further work on that, which I may or may have not filmed or demonstrated on this video so far, but essentially that amp needs 4 new output valve sockets and it's going to need 4 new output valves. Right, so I've managed to find the correct schematic for this amp. I want this one here, which confirms that the heater winding, when wired for 240 volts over here, does have a 5 amp fuse in the heater winding. So this little label that we found inside the amp is correct. It is correct, and the 10 amp fuse that was in the amp is not. So what are we going to do? So anyway, this fuse holder was the correct fuse holder for the heater supply. My only confusion was that obviously it's a red wire and it says it's green, but that all they've done is, you can see, spliced a red into a, not spliced, but attached. Anyway, that's now in. I've turned the amp on. You can see I've got the light bulb in circuit and the dual light is now working. So we do have, well, we had 2 blown fuses. One the heater fuse had popped and the, what am I trying to say, the mains fuse had popped. So what we're going to do now, because we've got a light bulb limiter and we can do this, is we're going to spin this over and I'm going to install the output valves one at a time to see what changes. Because we've got the light bulb limiter, we're not going to be at risk of anything. Now, this is the one that we suspect is faulty, but that doesn't mean the others can't be too. So we'll start with this one here, into this position. The bulb will glow brighter as the heaters draw more current. That's now in. Now that's interesting. Nothing changed there. Is my dual light still on? My dual light still has power. Let's just measure the pins in the sockets. 1, 2, and 7. Yeah, there's heater voltage, but that one did not light up. Let's do the next one. I'm just not getting any filament glow. Yes, I am. Yes, I am. I can see it now. Right, this one. Yeah, it's definitely pulling more current now. Okay. And finally, the faulty one. So the bulb is definitely glowing brighter now. I don't know if it's coming across on camera. Okay, so all valves are currently lit. And the amp is coming up to temperature now. So the light bulb is out of circuit, by the way. So we're currently drawing 147 watts. 150. So 150 watts at 240 volts is 0.9 amps. And the mains fuse is 2 amps. So that's about correct at idle. Half. Well, I'm just going to leave this running for a bit. Leave this running, see if anything changes. I mean, all 4 of these very rattly, so my recommendation would be a new quad. Fuses don't blow for no reason, right? And that heater fuse that did pop, it was twice the value that it should have been, and if that popped, then there's definitely something wrong. So do we have a dodgy set of output valves? All seems to be running fine for the time being. I'm going to leave this running for a bit. I'm going to monitor everything, see if anything changes, and I'll come back. The Johnsonite says, "Hi Chris, do you have any suggestions of how to structure the layout in a chassis that is perfectly square? I have a project with a footprint of 19 by 19 centimeters, which needs the full array of transformers and tubes. Single-ended, but multiple preamp tubes. It's going to be it's going into a small combo." Right, okay. So don't have 360-degree access to the tubes when everything is installed. The standard principles apply, which would be that your AC input, your mains voltage input, is as far away from your guitar input as possible, far away from the preamp as possible. So in a square, that would be diagonally opposite. Treat it as though it's a rectangular chassis, but just truncated. You're still going to follow the same design principles. And go from there. There are some old hi-fi designs that were built into square chassis that you could follow, I guess. You could look at how things were done that way and work it out from there. That might be a reasonable way to do it. But yeah, I mean, standard rules apply. Doesn't matter what shape your chassis is in. It's where everything inside it is relative to everything else. So that's what I would do. if I wasn't wiring up this amplifier right now, I would sit down and do a quick drawing for you, but it's quite simple. Quite simple, really. Guitar inputs as far away from your mains inputs, and then you kind of work your way inwards. Bad news then, guys. The amp was running for around 25-30 minutes. All seemed to be okay, then all hell broke loose. That valve, the one that we suspected, started arcing, started making some funny noises, lightning flashes inside, boom, 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 and it is kaput. So we are going to need, unfortunately, a new matched quad, which I don't have on the shelf. I've only got matched pairs. So I'm going to have to order up a matched quad for the customer. I do need to ring them and get permission and explain what I found. So we need a new matched quad of 6L6s for this amplifier. Is all it really needs. We'll get this thing up and running, we'll get it biased, we'll give it a service while it's here, make sure everything's good. I'll talk to the customer about those IC caps as well, but I suspect that he won't want them doing, but you never know. If they do, we can go ahead and do that. So that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up, or your comments and questions down below. Subscribe if you haven't already. If you're feeling super generous like these guys have, why not join the channel, support me that way, and I will catch you all at the next one. Morning everyone, you join me on what is a glorious day. It is Bank Holiday Monday, which is public holiday here in the UK. Not sure Scotland's having it, never can remember. But I'm finally getting round to doing a job I've been putting off for ages. Mainly because race season takes over. You know, I'm running the race car, the van needs looking after, Mrs. Riff's car needs looking after. But one job that I need to get done on the car is to do the rear brakes. I need to do the discs and pads, or rotors as you Americans like to say, and I've got some suspension bits as well. So as today appears to be the last proper sunny day for a long time because the rain is coming, we're going to crack on and get these brakes done. So I figured I'd take you along for the ride because, you know, I'm not working on amplifiers today. So I've got to need to film something, don't I? Anyway, what's going on there? Sorry. Whoops. Right. 1, 2, 3, 4, 5. And off we go. Right, let me show you. So, the rear discs on a car obviously don't do anywhere near the same level of braking effort as the fronts. In fact, on this vehicle, a Land Rover Freelander 2, or LR2 as they called it in North America, the split is roughly 90-10. So 90% of the braking at the front, just 10% at the rears. And therefore, especially on a road vehicle, the rear brakes really get hot, rarely get any use, and as you can see, the level of corrosion that builds up because the pads just aren't working hard enough to generate the heat to keep these things clean. So you always get this, and it's a nightmare. And I bet there's loads of life left in the pads, but the disc is now beyond service really. With my annual inspection coming up, MOT, in, I think it's December. I want to get these done now while I've still got a chance. So, but while I'm here, also the handbrake, parking brake, e-brake, whatever you want to call it, also needs adjusting because it's a bit crap. So all of this is going to come off, be cleaned, and then, as I said, I'm also doing my anti-roll bar drop links as well. This bar that comes down here, there's a slight knocking on both sides from the rear, and whilst I'm doing this job, it's easy to do those and they're cheap. So I'm going to get those done. But yeah, I'm going to crack on, take you along for the ride and get all this stuff off. Now, I haven't done the rear brakes on this car before. I've only owned it a couple of years. So But having that, I just spent most of the weekend doing brakes on race cars and other stuff, I'm in the mood to do them, so I'm pretty switched on. So I'm going to crack on, get this caliper off first, then I've got to back the handbrake off, then I can get the disc off. Now inside the disc itself, in here are handbrake shoes, so the parking brake is inside here. It's like the old system, it's not the electronic handbrake, so I need to figure that all out as well. Okay, you see, there's actually not a lot of life left in those. Not as much as I thought there was. And they're not moving very well. Get that one out. Some slight uneven wear. We get you in the light. Yeah. Maybe it is time to replace them then. Maybe it is time. Also, according to the instructions, you don't apply any grease to these, you know, to the ears, which I can't believe is correct because they're in there pretty tight. Yeah, that one's pretty shagged, look. Pretty knackered. Well, glad we're doing them then. There you go, the little clips that hold the pads in place. They're crusty. I think I've got new ones of those. Can't remember, if not I have to clean those up. Right, I need to get this caliper out. I've had a look at the slider pins and they are greased nicely and they're not too bad, so they should clean up reasonably well, I would have thought, which is good. Which is good. Right, what size do I need for these caliper bracket bolts? That looks like a 16 to me. That's a 17. Definitely smaller than 17. I knocked my socket box over and they went everywhere. So they're all mixed up. Come on. 16. 16. 16 seems too big. Are they 15s? 15. 15 is correct. Thank God for impacts, eh? Ooh. Ooh. Might have to get the breaker bar on those. One moment. Right, caliper bracket is off. It is rusty, so I'm going to give that a good old clean up and sort out. Anyway, now what I've got to do is back the handbrake shoes off. So I've got to take this little cover off here. Doing this one-handed while holding a camera is not recommended. Now what I've got to do is rotate this until we get to the point where the adjuster is inside, which I believe is roughly here, and then I've got to there's a little spline thing. I'll show you once I've got this off, and I've got to back it off, and that pulls the shoes away from the inside of the disc drum, whatever you want to call it. Got to get in that hole somehow. This should do it, and then we can pull this off. Right, that's backed off. Now I've got one chance to get this out. Oh, she don't want to move. Damn. Little bit of heat should do it. Ah, winner. Winner, winner, winner. That was in there. Make sure we clean that up so that doesn't happen again. A bit of anti-seize on there next time. Right, can we get this disc off? I mean, she's moving. I think we need to back that parking brake off even further. Problem with stuff not being done all the time, or regular maintenance, is you end up with absolute bullshit like this, where you're just fighting. That doesn't sound good in there. This is going to be an all-day ordeal. You just know it, you can feel it. Well, that now feels like it's tighter on there. Probably moving it the wrong way. Let's try the other way, shall we? Don't worry, I've taken the handbrake off inside the car. Yeah, that's coming looser now. So I'm just turning the adjuster. Once I've got this disc off, I'll show you what that looks like. Oh, we're getting somewhere now. Yeah, absolute winner. Right. And there she is. And we have some material left on these shoes. Not a lot, but there is some. However, there is a crack up here. So I think that they are the original Land Rover shoes. They are getting thin. It might be a case. God, they're very thin actually. In the near future, I'm going to need to get those replaced. But I'm not doing it now. Here's the adjuster. This thing here, you just turn it with a screwdriver. Like that. And that moves things in and out. Sorry, you can't actually see what I'm doing there. Right, I've just been giving this thing a clean up, and the date code on this hub is the 11th of August 2008, which is a month before this car was registered. So that's the original rear hub for the car. Very cool. Cleaned all this up now, just re-greased some points. One thing I love to use, and this is amazing, is this stuff. It's brake service paste. And it's like the best anti-seize grease stuff for all this kind of job. It is amazing. Fortunately, you can only get it in Germany, so you have to import it, but it just works great. I use it on all the race car stuff. But anyway, that's all that done. So I can put my new discs on, get my new pads on. I've got to push back the piston in the caliper. It's up there at the moment. Re-grease my slider pins, get all this back together, roughly set this adjuster for the handbrake, and then it can all go back together and do the other side. But this is going, I shouldn't say it really, should I? But it is going surprisingly well. Oh, it's getting windy. It's getting windy. Clean the disc up before it goes on. See, look, that's a crack that comes off. Okay, so I want my... Oh, look at that. Look at that. Tiny bit of anti-seize on that, because we don't want that seizing again, do we? I haven't looked up what the torque spec is. A bit silly of me. Tell you what, dab on there as well. There you go. Where's my little thing gone? Oh, torque wrench, one moment. Right, apparently this is torqued to 35 Newton meters. That seems a lot, doesn't it? Then again, it is a big heavy vehicle, so 35 on the nose. There you go. Bish bash bosh. Right, that's looking good. Okay. Apparently what you're meant to do now is I now need to take this round again, tighten up the adjuster, the one I showed you earlier, until you can no longer turn the disc by hand. So I think it's going to be that way, isn't it? It's turning well at the moment. Okay, can't turn that by hand, so we'll back it off. Probably gone too far. There you go. One more. Oh, I can't turn that by hand now. And it says I now need to back it off 8 turns. I think it's 8. I need to go double check. Yep. So I need to do 8 notches, it says. Not 8 turns, but 8 notches. 8 of the little, you know what I mean. So can I see it? We're going to go 1, 2, 3, 4, 5, 6, 7, 8. And that should put us, it should make it easy to turn. Yes, it does. Look at that. Whoa. Right. Pop that back in there. And now we can do the caliper and the pads. With these 15s. They were 15s, okay. Ba-bum, bum, bum, ba-dum. Must be that way. Like that. Where'd the other one go? Here it is. Tiny bit of anti-seize. Apologies, I'm not in work mode, so I'm swearing today. You'll have to deal with it. They're snug. And they need talking to 110 Newton meters. I don't know what that is in pound feet. 78, 79 pound feet. Which seems a lot, but again, it is a heavy vehicle, so maybe that is correct. Maybe that is correct. So this is 112 minus 2. There you go. Well, that was satisfying, wasn't it? It's looking good. It's looking really good. Right, let's find these clips, shall we? Yeah, new clips. Oh, look. The brake pads came with all new bolts and stuff. In that case, then, we are going to pull that one out and put the new one in. We're definitely not going to reuse the other one. We've got a new one, we're going to use it, aren't we? I'll talk about that Torx. That should come straight out now. Yeah, it does, look. Right, so we'll get the new one. Bit of anti-seize again. What was the torque speculation on that? Do you remember? Was it 100? Was it 35? 35. There you go. I like that. I like that a lot. Right, these clips then. So these pad clips then should just go on that way. Oh, don't you not fit? I'm not having this. Normally, when you're filming something, then where you're doing both sides, you do one side off camera, and then you film the second side because it makes it look. It makes it look like you know what you're talking about. But it's not going to be the case on this one, I'm afraid. Why is that bent over? Oh, wait, it's meant to be to hold it in place. Bloody corrosion, look. Where'd the other one go? Here it is. Yes, but I haven't done that, which means I'm working this out on camera, and it's not a good look, is it? It really isn't a good look. Let's do something for the first time on camera. That really makes for good content. Well, actually, maybe it does. Maybe it does make good content. Who knows? Maybe you're enjoying seeing me struggle. That disc should still turn. It does. Good. Right. Pads. Are the pads sided? There's 4 of them in here, and they're all the same, so no. Put a little bit of paste on the ears. Anywhere else where they're going to slide? Just there. I like it with this brush as well, because you can be really accurate with it. Don't get it on the friction material though. Come on, you bugger, get in there. There we go. Ba-bum, bum, ba-bum. Painting on my brakes. Pads are in, look. And if I compare new versus old, you can see just how much they were worn. Right, need to push that caliper back, grease the slider pins. Where's the caliper gone? There it is. And then I can crack on with that drop link. So I've got this piston pushback, wind back tool. But unless it's a directional screw type, which this isn't, this is just an in and out, then sometimes just a C-clamp is easier, but I just keep cranking on it and it pushes that piston back. And this one is moving nice and freely, which is a good sign because it means it's not seized. Because I really don't want to be dealing with that. Clean off the slider pin at the top, which is in great condition actually. Get some new grease. I always use Redline CV2. If it's good enough for a race car, it's good enough for a road car. Tiny bit of grease to that pin, and in she goes. And that moves beautifully. Right, we're in. Look at that, beautiful. Right, where's the lower pin? Here's the lower pin. Here's the lower pin. Let's clean that one up as well. I'm going to say it again, this is going surprisingly well. The only thing that fought me was that Torx screw, wasn't it? Still got the other side to do. I guess this is part of the benefit of doing this stuff in the summer. In the winter, everything just becomes so much more difficult. Lower slider pin. Oh no, that one goes in first, doesn't it? That's right. And then that goes to that side of it. Oh, I'll just rip my glove. We do have a new slider pin bolt. I've actually got one for the top as well, but I don't want to take that one out unless I have to. So what size is that? 13. You were on my spanner, how dare you. I'll snug that up. Oh, that's turning as well, which will be the 15, won't it? No, it was the 16, wasn't it? Such odd sizes on this car. Such odd sizes. There we go. And then torque to 30 Newton meters. So 28 plus 2, budget torque wrench. There you go. 30 Newton meters, done. Now, do I swap out the top one at the same time? Should I be sensible? I think I need to be, really, don't I? So the breakaway torque on that was less than its tightening torque. And keep that as a spare, get my new one. They come with Loctite on them, it's really cool. Right, on the other side, I'll do that job first. $30. I believe that is this side done. I believe that is this side done. It should now turn on its own nice and freely. Tell you what, I'll just go and pump the brake pedal, seat those pads, and then we'll check it again. 1, 2, 3, 4, 5 pumps. Check my brake fluid reservoir. Yep, looking good. Right. Excellent, so it still turns. Direction of travel. Yep, beautiful. Right. What I'm not going to do, I'm not going to refit the wheel. Sorry, I probably just splashed you with brake clean, sorry. I'm not going to refit the wheel until I've done the final handbrake adjust inside the cabin. Cabin? What do you call it? But that is now, that side done. Excellent. Right, I'm going to do the other side, probably stop for some lunch, and then I'll bring you back once we're on the inside and see where we end up. Right, that is both sides now done. So rear disc and pads done, handbrake adjusted at this end of the handbrake cable. We need to do inside. Also done my drop links as well. You see, yeah, there you go. So that's all in, all done, all dusted. I'll just show you the disc from the driver's side. Whoops. See, again, loads of corrosion inside and outside. The handbrake shoes were slightly worse on that side, so I am going to keep an eye on them. Pads, again, some life left in them, but not great. I mean, the minimum limit is 2mm of pad material remaining, so we've probably got about 3mm there, but if I'm putting new discs on, we're putting new pads on. So that's all of that stuff pretty much done. Definitely worth doing. So now I've just got to do the internal handbrake adjustment, and then I've got some other little bits and pieces, other jobs I want to do on this. I need to do the rear diff oil. The rear diffs on these are quite weak, and so regular oil replacement is recommended. Let me show you where it is. Here it is, just up there, centre of the screen. So there is no drain on it, so you've got to use a syringe to get rid of what was in there and then fill it back up again. It's a fill and spill, so it's easy enough to do. Right, I need to get the handbrake adjusted first, so I'm going to do that next. Right, so in the rear of the vehicle, behind this console here, zoom you down, sorry, is the adjustment. So this is what the handbrake lever itself pulls on to tighten this up. Now, if I come round to the front and get in there, if I pull the lever, sorry, you'll see the cable move. Yeah? So that all needs adjusting. And ideally we want it on, so if I pull it up to where I want it, it's about 4 or 5 clicks, right? And that's still a bit loose. So I'm just gonna release the handbrake, 16mm spanner, and I'm just going to tighten it, which should be this way. 1, 2, 3. So with the handbrake off at the moment, I can still turn that by hand, right? Crack my lever up. That feels better. And I can't turn that by hand anymore. Perfect. So I'm going to stick the wheels on and then see how well that holds. Right, so job's all done, car's all back together, done the rear brakes, done the diff fluid, and now there's a procedure you've got to do which I think is absolutely bizarre to help bed the handbrake shoes back into your new disc, which you've got to drive along a road to 25 miles an hour, pull the handbrake on so you can feel its effect, one more click and hold it there for 400 meters to bed the handbrake shoes into the new disc. Here you go, I can feel it now. Oh, that's weird. So we'll just come along here and then we'll turn around. Take it off. Oh yeah, you can feel the difference. That is strange. I've never had to do that before in a car. Right, we'll just turn around here, then head back to the workshop. Hold on. Oh, the pedal's feeling much better. Hold on. Fire engine. Right there. Is anyone coming? No, we'll go back again. Right. Accelerate. Woohoo! Up to the right speed. Handbrake on. Can feel it now. 400 meters like this, and then what I can do after this is just readjust the adjuster behind the center console. I can feel it, really feel it dragging now. Loving this. Right, that feels like 400 meters. Back into the farm. We'll do our final adjustment. Gonna get my spanner again. Was it 16mm, wasn't it? Yeah. And that should be our bank holiday car maintenance jobs done. The only thing this car needs before the winter is a final oil and filter change, which is due next month. So we'll find a dry day to do that, and then it's good for the winter.